So today we are talking about series. A series is the sum of indicated terms of a sequence. There are two types of series. There's a finite series and an infinite series. A finite series has finite amount of terms, so it has one that starts and then one that ends. An infinite series, on the other hand, continues forever. All right, it never stops going up. Again, a series just means I add up all the digits of a sequence. So we went over what sequences were last time. We showed this one right over here. This right here is an arithmetic sequence where we're going up by 2 every time. We're just adding those all together. Okay. Then we're going to go into more of the new part right here. This is what we're going to call sigma notation. This is how we annotate a sum. Because as we can see here, it's not too bad when there's only 5 terms, but some of these will have 25 terms and sometimes even up to, I think 35 terms is what I have the most on here, but it can go as many as you would like. And it'd be really annoying to have to write out all 25 terms. And so instead we made this right here called sigma notation. There's a couple pieces to the sigma notation to focus on, specifically these 3 arrows right here. There's a lower limit. That's where we start our function. We have our upper limit. That's where we end our function. And then we have our formula. That's how we know what we do with our sums. So with this lower limit, for the most part in our class, we're going to always set it equal to 1. The reason we do that is because it's kind of nice and easy to start at 1, so we can just plug in 1 and go. And it also makes our upper limit the same as our end value, right? Our total number. But we'll go over that a little bit later. Make more sense when we get down to these problems down here. Then we have our explicit formula. This is the same thing we went over last time. We also called this a rule. So that's that one where we went over that a sub n equals my common difference d times n minus 1 plus a sub 1, all that type of stuff. Now, if I were to expand this out, it would look something like this. But I would get that by taking this 3n and then multiplying and then plugging in 1 through 5. All right, so I plug in 1 first, plus 3 times 2, plus 3 times 3, plus 3 times 4, and then finally 3 times 5. Noticing that we're going up by 1 every time, all the way from my lower limit 1 all the way up to my upper limit 5. 1, 2, 3, 4, 5. That's how we get our function right here. Now we can take it one step further and we can have what's called an infinite series. That's where we have the top number, our upper limit, being an infinity symbol right up here. That's saying that it starts at 1. We started our first term, and then we just go up until we hit infinity, which is impossible. All right. Are there any questions on how we write sigma notation so far? Just mostly on the lower limit, upper limit, and explicit rule part, before we practice some a little bit more. All right then. See anybody jumping up to it, so we'll move on then. Clear this out. Now we're going to practice with this a little bit. So First problem right here, find the sum of the given series. What we're going to do is just like we did up here, we're just going to plug in all of my numbers between 1 and 4. We're going to start with 1 over here. I'm going to go all the way to 4 over here. Plugged in 1 right here. Got 2 times 1 plus 1. Plugged in 2. Plugged in 3. Plugged in 4. All the way down. Right. Then I simplify a little bit, and I solve and get my final answer of 24. Are there any questions on that process of rewriting this by expanding it out and then simplifying? Yeah, so that all the 2's come from this thing. So I just took my formula right here and I changed the n right here with the numbers 1 through 4. Because it starts at 1 and it ends at 4. So I went 1, 2 times 2 plus 1, 2 times 3 plus 1, and 2 times 4 plus 1. So we're stepping up from there. So let's try it again over here. I was going to have you guys do this on your own, but last class barely finished it, so I want to make sure that we have enough time. So I'm going to go over it with you all. You guys are kind of going to walk me through it. So my first step I'm going to help you out with. I go insert equation. I'm going to scroll down a little bit so that my boxes still line up. That's nice to do. And I get my first one should be 10 times 1 because I'm starting at k equals 1. What should my next step be? What do you tell me? Ten times 2, perfect. Times 2. And I keep going in that same pattern, 10 times 3 plus 10 times 4. And where do I stop? Perfect. Stop at my upper limit of 6. I actually put an extra one here. Delete that. Plus 10 times 6. Now that went a little bit off my paper, so I'm going to highlight it all. I'm going to go down by 1. Perfect. Got some answers in the chat as well that I like. Good. So then I just multiply a little bit, simplify. 10 times 1 is 10. I like to have a new equation. Makes it look a little bit nicer. 10 plus 20 plus 30 plus 40 plus 50 plus 60. Can anybody tell me what that equals when I add them all up? Perfect. So put it in the chat. 210 is my correct answer. That is correct. I'll give you all a second to write that down before I continue talking, so you won't have to listen and write at the same time. And always with any of these, if you don't want to write them down on your own, you can always take a photo at the end. Just let me know that you're doing that so that you have, so like leave it up on the screen. Right. So this right here is not too bad at writing them all out like this when I know that this is a small number right here, like 6. It's not too hard to write out 6 of these right here and then simplify. But if I got something like 20, it would be much harder. Right? And so that's where we're going to come into our formulas down below that'll make it much easier to solve bigger numbers of sums, where I'm not just summing 1 through 6, be a little bit bigger than that. Right? Before we do that, I want to go into how we write sigma notation, how we get our numbers and everything. I'm going to clear off my drawings. We're going to move down. First up, we don't actually need this right here. It's an extra space. So first thing I need to talk about is we need three different pieces of information. We need our lower limit, we need our upper limit, and then we need our explicit formula. Can anybody tell me what my lower limit is? So someone give me my upper limit. It's my lower limit. So people have given me my upper limit, not my lower limit. Anybody tell me my lower limit should be? Does anybody have a guess? I want to just try and throw out a number. That's correct. So someone said it right. It is 1. So remember, my lower limit that we're going to always start at is n equals 1. Now, can anybody guess what my upper limit should be? I already have answers in the chat that are correct. My upper limit should be 4. I get that number 4 by adding up however many terms I have. So I have 1 term, 2 terms, 3 terms, 4 terms. So my upper limit is going to be 4. 1, 2, 3, 4. Now what we're going to do, so I have my limits. I have my lower limit, n equals 1, my upper limit 4. And now we're going to be able to actually do the stuff that I have written here. Now what we need to find, which is just like what we did last time, is our explicit formula. To do that, we're going to use this down here. A sub n equals d times n minus 1 plus a sub 1. To get d, we subtract any two of our numbers. Usually subtracting the first two is probably the easiest, but sometimes you might want to choose a different pair. 7 minus 4, always the second one minus the first one, gives us 3 down here. Then I have my a sub 1, which is always just the first term. So whatever my first number is. Since the first number is a 4, my a sub 1 is a 4. So now let's make our equation. Turn. The equation a sub n equals my d, which is 3, times n minus 1 plus a sub 1, which is 4. Now that is completely legitimate answer for my thing. The book wants you to start distributing and simplifying. Right? So if you leave it like this, a lot of your answers are going to be incorrect. You must simplify also. So distribute the 3. I get 3n minus 3 plus 4, which equals 3n plus 1. Especially on a multiple choice question, like something that happens on a test or a quiz or an exit ticket, make sure that you're checking to make sure that your thing fully matches. Don't just try and take a shortcut and see that this is a 4 and then it matches this one, so I'm going to choose that one. Remember that sometimes I have to simplify. All right? Make sure it matches fully. After that, we're going to take our equation right here, and plug it into here. Again, this can be also equal to, I'm going to copy paste this right into it, control copy, control paste. I'm going to change this 3n minus 1 plus 4 to a 3n plus 1. This is probably the better answer to have every time, to simplify every time. Make sure that you're doing that in your problem. Are there any questions on this first problem that we've done so far? All right, just like before, let's go through B together, this one, before we move on to our next stuff. So the first thing I need to do is I need to find my lower limit. Go in the chat and tell me what my lower limit should be. Perfect. N equals 1. What about my upper limit? What should my upper limit be? Let's see how many people in the chat can tell me what my upper limit is. So currently I have 1 for 1, 2 for 2. Who can tell me what my upper limit should be? But those of you in class, put it on your hands how many I should have for my upper limit for B. It's a good answer. Not getting very many answers in the chat, so I'm hoping that more people started doing stuff in there. My upper limit should be my number of terms right here. So I have 1, 2, 3, 4, 5, 6, 7 terms. So my upper limit should be 7. Just like before, we went through our lower limit, we went through our upper limit. Now we need to find our D. Can anybody tell me what my common difference D should be for this problem? Someone got it very close to the correct answer. They're slightly off. Perfect. So my answer should be -2 right here. So I can go 4 minus 6, which equals -2. Next thing I need is my a sub 1. What should be my a sub 1 be equal to? Good, that's the correct answer. Can anybody else tell me? Again, the same 2 people in the chat telling me everything. What should my a sub 1 be? You got any ideas? Green Dom? What should my a sub 1 be? Not quite. So a sub 1 over here was that 4. What does a sub 1 stand for? Remember? Not quite. It's close though. It's good matching up things. What does a sub 1 mean? Do you remember? So a sub 1 is my first term of my sequence. Okay. Perfect. So it's 6. So that a sub 1 is equal to my first term, which is 6. Then we're going to go from here, getting our formula. So return new equation. A sub n equals d, which is -2, times n minus 1 plus 6. If I distribute that out, I get -2n plus 2 plus 6, which equals -2n plus 8. Which of course just barely doesn't fit. So we have to go down a little bit. Now this is the key part. If you tuned out for a while, this is the part you should focus back in on. So I'm going to show you how to get to your sigma symbol and how to turn it in and plug it in and everything. So I come up here to new equation. I go to the fourth one over. It's going to be on the bottom left. Now the trick to this right here is that I can only use my left and right arrow keys to move around. If I try to go up and down, it moves me outside of my thing instead of moving me down. All right, so left and right arrow keys are the only ones that work. Left, right. Bottom part's pretty much always going to be n equals 1. Top part is going to be my upper limit, which we found to be 7. This right here is my formula, which we found to be negative 2n plus 8. And that would be our answer right there. Are there any questions on B before we move into our next section, arithmetic series? Any questions on anything we've done so far in our definition section? Yeah. Technically, you're supposed to put n equals 1. If you didn't do it, I wouldn't mark you down points, you know. But technically, you do that because it could technically, when you get to higher levels of math, there'll be more than one thing in there. So it might be an I and a J. And so we have to denote it somehow, but it doesn't matter. Great question. Any other questions? So how did I get 7 again? That's a great question. I count up my number of terms. So I have 1 term, 2, 3, 4, 5, 6, 7. My upper limit, I could say, is really just my turn again. So we have a nice space. We have space. Number of terms. Now this number of terms thing is only true if we start at n equals 1. If for some reason you start at, like, let's say n equals 0, then we'd have to go 1 minus this number. Get my upper limit. Right? Because you're moving back 1 for everything. You'll see some people like to do that. Right? I like to start at 1 because I think it makes it look nicer, number of terms look nicer, all that stuff. But some people like to start at 0. Can't fault them for being wrong. Any questions? All right, let's move into our next section then. I'm going to give you a little bit more time to write this down if you haven't already written it down, then we'll move on. All right, clear off my screen so I don't have those weird boxes. We're talking about arithmetic series now. Again, I included this formula because sometimes you need the explicit formula. This right here is the formula we're going to be using to find our series. All right, the sum of our series. S of n means sum of the n terms equals n over 2 times my first one plus my last one. Right. This right here is really just making it an average. I'm getting an average and then I'm multiplying it by that n value. You'll see some cool geometric reasons for why this formula works. If you want to go check them up online, I have those if you would like to see them at some point. I don't include them because technically we no longer have to have, have not had to have geometry for this class. And so I don't know where your geometry skills are. But if you would like to see it, why this is true, just come let me know and I will show you. Well, let's use it. All right. Let's say that we know it's true. We believe it to be true. Let's plug it in and check it out. For A right here, what we're going to do is we need to find 3 different things. We need to find our n. We need to find our a sub 1. And then we need to find our a sub n. Our n is whatever number is up top. All right, nice and easy. It's my number of terms. My a sub 1 I get from plugging in 1. 15 minus 10 times 1. So I replace the n right here with a 1. 15 minus 10 is 5. I have my answer. Then I find my a sub n, which is a sub 35. A sub 35 equals 15 minus 10 times 35, 15 minus 350, negative 335. So now I have the three pieces I need. I have my n, I have my a1, and then I have my a sub n. First term, last term, number of terms. And then I plug it in. Let's think of why not. There we go. Plug them in. Use a calculator to simplify, all that good stuff. Again, I said use a calculator. It is much easier to use a calculator on this than to try and write it out on paper or however you're going to do it in your head. So make sure you are using that calculator to make sure you get the right answer. Some of you are not great with calculators at the moment, so it might be a good idea to come by office hours to get some help on those calculators. Okay? We can go over how to use whichever calculator you're using, how to use it properly, especially if you're using your phone's calculator, which has some hard parts about it. Okay? Now I'm going to set you free to work on B and C in a second. Are there any questions on B or C before I set you free? All right, or A. All right. I'm going to give you, let's say, 4 minutes. Sounds good to complete these problems, and we're going to go over them. One of the people from the chat will be doing one of the problems. One of the people from in class will be doing the other problem. Nothing. Sometimes I put parentheses because I'm used to putting parentheses. All right, so that's the end of our 4 minutes. Let's go over B first. I'm gonna let that person in my class. I rolled a 4 on a 1 through 4, so that is going to be Riley. Can you explain to me how you did B right here? It's my first step. All right, let's walk through it. So our first step is to find our N. What's our N? So our N is that top number, right? So our N is going to be that 25. Let's go through the next part. Now we need our A1. That's our first term. How do we get our first term? So I go 5 times 1 minus 7. What does that give me? -2. So I got my A1. Now I need my A sub n. Got my new equation. For us, our N is 25. So how do I get A sub 25? How do we get A sub 1? We want 1 this time? The last time we used 1 because we wanted A sub 1. What should go in our parentheses? Perfect. What's 5 times 25? Perfect. What's 125 minus 7? Perfect. Ran out of room. We're going to shrink that down a little bit so that it fits. Now we're going to plug it all into this equation up here. Nice for being on a computer, I can copy paste it. My N in this case was 25. N's 25. A1 is perfect. A sub n is perfect. When I simplify this a little bit, I'm going to end up getting n sub 25 equals, let's leave it as 25, question bar, 25 divided by 2 times 116, which ends up being, I'm guessing you don't have a calculator right on you, 1450. Again, too big, so I'm going to shrink it down a little bit, but it fits. Are there any questions on that process? Finding my N, finding my A sub 1, finding my A sub 25, then simplifying. All right. Got it. So let's go through C now. I don't see any questions. If you come up with a question, let me know. We'll go back to it. Dylan, you got chosen for that?
Yep.
So what is my first step for this one?
Well, so your first step is to, so we know n is 1, so our first step is to find a1.
Not n equals 1, but n equals my top number of actually 4.
Oh, yeah, the top number. Sorry, my bad. But so a1 would be 6 times 1 minus 6. And then a4, which we also
What does
need,
that give us before we move on?
it's 0.
Perfect.
And now we need a4, which is 6 times 4 minus 6.
What does that give
And
us?
that gives us 18.
Perfect. Now what do we do?
So right now we need to use the what's it called, like the arithmetic series thingy to make S4 is oh, okay, sorry, my bad. S4 is equal to 4 times and then A1 plus A4 over 2, which is 0 plus 18 over 2.
What does that simplify and become?
That ends up becoming 36.
Perfect.
And that's our answer.
Their answer
Sorry, I was
looks
late
great.
starting that, by the way.
No problem. That was perfect. Great wording. Any questions on this one? All right, this would be a great one in case you can't write it down very fast. Quick picture. Nice and easy. We'll leave it up for about another 10 seconds, then we're going to move on to our next problem. Let's move down a little bit. We're going to skip the word problem for now. Right? We're going to get to that in a little bit. I want to make sure that we have enough time to complete the geometric series section as well as my infinite series section. Those are the two main things we're going to go over. So again, up top here, we have our explicit formula right here that we learned last class that sometimes you'll have to use. Right? A sub n equals A1 times R to the n minus 1 power. All right. Again, that's our explicit formula. That's how we get that part way up here, right in here. Cool. So if we're looking at this right here, next part, we have our geometric series sum right here. This is the formula for it. A sub 1 over 1 minus Rn over Rn. Let's write out what some of these things are. So again, my A sub 1 is my initial value. My R is my common ratio. To get my common ratio, I go fraction bar, A sub, whatever I want. Let's call it 2. Nice and easy. Over A sub 1. All right, that's how we can get it nice and easy. It can be any two numbers that are right next to each other. 2 and 1, 3 and 4, anything like that. And then finally, we have our n, which is, make it look nice by making it all the same, number of terms. So that's what we're going to be finding. We're going to find our initial value, our common ratio, and our number of terms. Now, what's nice about it being already in this form is that our common ratio will always be whatever is being raised to that power. All right. Let's call my base. That's not a great E. Let's undo that E. Let's redo it. Of the exponent. So it's always that base number right here. That is my common ratio R. So if I'm looking at this, I have my A1 by plugging in 1. I have my R, which is that number inside the thing, right there. One thing I want to repeat to everybody to make sure everybody remembers, it's a very important thing that a lot of people like to forget. Anything to the 0 power, any number to the 0 power equals 1. I want to remind everybody of that. So this -3 to the 0 power becomes 1. And so we just get -2 times 1, which is just -2. Now that we have our A1 right here that we needed, we have our R from right here, and then we have our N from up top. We plug it into this formula right here, and we simplify. Again, I did not do this by hand. I plugged it into a calculator, and it told me what that was, and I slowly simplified. If you would like to plug this whole thing into your calculator and then just get a final answer out instead of simplifying like I do, that is completely fine. I like to simplify it just so that I make sure I'm keeping the numbers correct. Are there any questions on how I did this problem? Finding my A1, finding my R, or plugging in the values? Let's go through 2 together then. Get a little bit more practice with it before I set you free. Turn, backspace so I have most of my room. My first step every time is I need to get these 3 things: my initial value, my common ratio, my number of terms. Let's see if someone who has not talked a lot today, tell me what my A1 should be. What should my A sub 1 be equal to? You don't have to give me the final answer either. Just tell me, what it should be, what should I plug in, what should I do? How do I get my A1? Say that again? Almost, you forgot that 4 part, so it should be 4 times 0.25 to the n minus 1, which should actually be 1 minus 1. Now, I did make a mistake and put n right here. It should not be n, it should be k. Thank you for reminding me. I simplify this right here. I end up with 4 times 0.25 to the power of 1 minus 1, which is 0. Anything to the 0 power is just 1. We have 4 times 1, which equals 4. Then we need to find our next thing, which is our R up top. Who can tell me what my R should be? Good, that's one correct answer. 1 for 1 so far. Anybody else tell me? Perfect, that's 2 correct answers. I'm going to take that. 0.25. I'm also going to shrink this down a little bit so it fits on one screen. So let's shrink down all of this, actually. Let's go with a 12. That's too small. 14. There we go. Turn. Myself some space. So now I have my A1, I have my R. Anybody tell me what my number of terms is? N. Theo. What's my N? So my n each time is my number up top. What's my upper limit for this problem? So that's my lower limit. The 1's my lower limit. It's my upper limit. Perfect. So my n equals 5 in this problem. Remember, I'm always looking for this top number up here, all right? So it's always going to be this number up here. That's always going to be my n for all these problems. Whatever number's up top. So now that we have my number of terms from that right there, we're going to plug in some numbers. I like to copy paste things because it's easier that way. Control paste. I might actually even move this over so that I have some even more space. I'm just going to plug in all my values. My n in this case is 5. A1 we found to be 4. R is 0.25. N is 5. R is 0.25. Then I've already done the math myself. That is equal to, let's make sure I get it right, 5.328125. Now that is a really big number. We probably won't write out that whole number. From now on, more than likely, there'll be something saying like round to the nearest whatever it is. For my class, for the most part, I want you to round to 2 decimal places. 5.33 be what I want you to round to. So if it's not stated in the problem that it wants it to be to 1 decimal place or whatever, we're going to go to 2 decimal places. Are there any questions on this problem 2 before we move on to infinite series down below? Again, if you're completely lost, you got to tell me. There's no way for me to know unless you tell me. All right. Let's move down into our last new little thing. Infinite series. An infinite geometric series follows the following pattern when I'm trying to find the sum. S sub infinity equals a to the first, a sub 1 over 1 minus r. And there's some specific reasons on why this is true from above. If you ever want to find out exactly why, let me know, and I will show you the reason. It does take some math that we have not gone over yet to really understand it, but it's not too hard to understand. Now, the trick to this right here is that this is only true if the absolute value of r is less than 1. Right? So 2/5 right here, this r value is less than 1. And so this problem can have 1. If we had something like above, where we had this -3, and this went to infinity, this would not be possible because the absolute value of -3 is greater than 1. Right? So we must have it be less than 1. Once we have that, we can just find our A1 and our R. Our A1 is by plugging in 1. Our R is the 1 inside. Plug in, simplify. And you're done. Nice and easy math. But I want to repeat to everybody, these infinite series only work if the absolute value of r is less than 1. All right. If not, they go off towards infinity or negative infinity, depending on the function. And they go up or down forever. So we always have to check if something is less than 1. And I will say, if you do have an infinite series, they actually have probably the easiest formula. This is probably the easiest formula to plug in for all of them, because you just have to plug in A1, and then R is pretty much given to you. Right? So it's pretty easy to actually solve and simplify. I think this is really cool if you think about it kind of more abstractly, in the fact that you can have a sum of infinite numbers that all add up. When I combine them all, they end up being 5, one whole number, which I think is pretty interesting to think about, where I can get closer and closer to 5 as I add up towards infinity. I will get exactly 2 5 in this situation. It's pretty interesting. Are there any questions on infinite series before we move into one last thing? So I'm gonna make a deal with you. You have a choice. You can either start the UDO practice and the exit ticket now and just start working on it, complete it, asking questions you might want to do. Or you can listen to me some more, talk about how to complete this word problem and going through a word problem and my kind of thinking through it, everything. Either option is up to you. You can listen to me going through it, or you can just start working. I'm fine either way. I will talk either way. This is mostly for those people that are kind of not doing well on word problems. They want some help with it. All right. So let's start in on it. When I'm doing a word problem, one of the best things to do is to underline any numbers. All right, like 20 rows. Great to underline. That's probably going to be something that we need. 5 seats, probably something we need. 4 seats. So I underlined all of my words. Next thing to do is to underline any of those math words that we see. Like the first row. That's probably something math related that we got to talk about. Increasing by. That's something we kind of talk about with math. In all. That's something we know about. And then something about the last row. The first thing I did was I underlined my numbers that I'm guessing are going to be kind of important. Then I underlined some of the words that we know in math kind of mean something, like increasing, last, in all. Before I even start the problem trying to do actual math on it, I got to look at what I actually want in the end. Let's choose a different color now. Let's go with our blues. So this first problem asks how many seats are in the last row. We actually had a problem like this last time where we ended up finding that the number of seats that are in a row, the last row is our A sub n. It's talking about the last row of my thing, my last n. Right. So now we kind of know what for this first question we need to find A sub n. For this second question, use a different color, blue. We need to find how many seats there are in all. When we kind of think about all, what we should think about is a sum, adding it all together. So for that one, we're going to be finding S sub n. That's sum that we've been talking about so far today for all of the different seats. All right, so now that we know what we're kind of looking for, we can use the information to kind of get what we want. All right, to find A sub n, I need to use my formula. A sub n equals d times n minus 1 plus a sub 1. So now I know what I'm looking for the first problem. I need to find d, I need to find n, and I need to find a sub 1. My d is my common difference. So I kind of look through 20 rows in the seats. I don't think that's my d. The first row contains 5 seats. That's talking about the first thing, but not like how much I'm going up by. So that's not really it. Each successive row increases by 4 seats. So that's where I can kind of see that increases by 4 seats every time. Means that my d right here is probably going to be 4. Right? Then we'll go to the next letter. My next letter is n. I look through my problem to see where my n comes from. N really means my total number. This one talks about 20 rows of seats being kind of like the total. So we kind of know that our n is going to be 20. Then lastly, we can kind of guess we only have one number left. So more than likely our a sub 1 is going to be 5. But we can also get that by the fact that it says first row and a sub 1 is the first number. So now that we have all this, we can plug in our numbers. Control copy, control paste. Replace my A1 with 5, my N with 20, my D with 4, this 20 as well. Then I do some simplifying. 4 times 19 plus 5. Oops. 4 times 19 plus 5. 76 plus 5. 81. Making sure to label it with what I have my units being, seats. Then I'm going to box my answer with the same color. Now I answered this first question, nice and easy, got it all done. Now we got to go on to our next question, finding our total, our S sub n. I'll probably start with writing down the function so I know what I'm going to need. I know that S sub n is equal to fraction bar n over 2 times a sub 1 plus a sub n. Now what's nice is that we've already found a lot of that information. I know that our n in this case is 20 over 2. Let's do something real quick. I'll erase this box real quick so that I have some more room. It's not cutting me off so much. There we go. Over my A1, which is, we know is 5, plus my A sub n, which is 81. I do some simplifying, I get 10 times 86. That's on to 6. That's a 6, which equals 860 seats in total. And then again, I box my final answer. Use this one. Right like that. That's kind of how I would go through one of these problems. Finding what I'm looking for first, realizing what I'm looking for, deciding what the formula should be, finding what the formula needs, plug it in, simplify, do the same thing again, plug it in, simplify, get my final answer. That's kind of how I go through word problems. That's how I was taught throughout my schooling. There's a whole bunch of ways to do it. You just got to find a way. Are there any questions on this problem right here? All right, if there are no questions, I'm going to set you free to work on your UDO problems and your exit ticket. Let me know if you have any questions on those. I'm here to help. Good luck.